All right, let's jump right into this explainer. Today, we're looking at how Java actually handles, stores, and transports data to solve real-world programming headaches. If you've ever found yourself writing the same repetitive code over and over to handle large amounts of information, you know firsthand that things can get messy very quickly. So let's unpack the powerful tools Java gives us to organize our data elegantly and move it efficiently in and out of our applications.
Seriously, just imagine the absolute headache of declaring individual integer variables for a massive class. I'm talking int m1, int m2, all the way up to 100. No way. It becomes totally unmanageable, your code bloats like crazy, and it's just a huge drain on your development time. There absolutely has to be a more scalable way to handle this kind of data.
So here is our roadmap for today. We're going to cover solving the data problem, leveling up data storage, flexible methods and arguments, mastering Java I/O streams, and finally, putting it all together. Okay, part 1, solving the data problem. Instead of 100 scattered, messy variables, we can just use a single array declaration, something like int marks array equals new int 100. Boom, you instantly allocate space for 100 integers. This one single line of code literally saves you from writing unmanageable, time-consuming scripts that are frankly an absolute nightmare to maintain at scale.
So the crucial point to remember here is that an array acts like a giant contiguous storage locker. When you declare it, Java actually goes in and blocks out a continuous, unbroken chunk of memory. Instead of your variables floating around all over your computer's RAM, they're sitting right side by side. It keeps all those similar values neatly organized under just one single variable name, like marks.
When you're working with arrays, you've got to keep these 4 core features in mind. First, every single item absolutely must be the same data type. You can't mix integers and text. Second, they have a fixed size. Once you declare it holds 5 items, that's it. It holds exactly 5 items. Third, as we just talked about, they're stored sequentially. And finally, and this trips a lot of people up, index counting always starts at 0. So your very first element sits at index 0, not 1. Moving on to part 2, leveling up data storage. Now, think of a 2D matrix, like a real-life grid or a spreadsheet. By setting up a multidimensional array, we can organize our students as rows and their specific subjects as columns. What does this mean in practice? Well, mark 001 instantly points us right to student A's Java grade. So instead of a basic flat list, you've suddenly got this highly structured, super efficient data architecture. Next up, part 3, flexible methods and arguments. Okay, let's talk about var-args, or variable length arguments. Before Java 5, if you wanted a method to add 2 numbers and then another to add 3 numbers, you actually had to write multiple overloaded methods. Honestly, it was incredibly repetitive. But var-args, it's an absolute game changer. It stops you from having to write all that repetitive code for different input sizes. By simply tossing 3 little dots after the data type, like int ... numbers, your method can suddenly accept as many arguments as you want to throw at it. Pretty cool, right? It is actually fascinating how much this cuts down on boilerplate code. Because you aren't writing a new method for every single possible number of inputs, your application becomes highly flexible and so much easier to maintain. Seriously, whether you call the method with 2 numbers or, 20 numbers, Java handles the flow completely seamlessly. Now, another great way to pass flexible data into your program happens right at startup. We can pass data the moment the program launches from the terminal using command line arguments. You know that familiar public static void main string args string? Well, that args is literally just an array of strings. If you execute a program by typing java test rita solve, those exact words are captured and stored as initial inputs straight into that string args array, right at index 0 and 1. All right, on to part 4, mastering Java I/O streams. So what exactly is a stream? In Java, it's a continuous flow of data. Input streams handle data that's trickling in from devices, like your keyboard, while output streams push all that processed data out to files or your screen. It is fundamentally how Java communicates with the outside world. In the Java I/O architecture, your program actually doesn't talk directly to the hardware. Instead, the stream acts as this sort of middleman, securely carrying data between your application and the keyboard, a file, or even a printer. It ensures you have a standardized pipeline, regardless of what the specific endpoint is.
Now, there's a really important distinction in how Java handles different formats. Byte streams operate on 8-bit data. We use these for raw binary media. Think images, audio files, PDFs, that sort of thing. Meanwhile, character streams use 16-bit Unicode. These are specifically designed for readable text, like text documents or source code, which makes sure all your character encoding is handled properly without any weird glitches.
To make all this streaming so much easier, Java gives us some incredibly powerful built-in tools. You're probably already familiar with system.out for printing to the console and systemin for taking keyboard input, but Java goes way further. We get classes like the scanner to easily read and parse our keystrokes, and the super-fast buffered printwriter class to effortlessly export and format our data.
Finally, Part 5, putting it all together.
Let's look at a college result processing system. It really brings all these concepts together beautifully. We can use 1D arrays to store 100 students' marks, 2D arrays to break down their specific subjects, and var args for totally flexible calculations. And then, after all that, we pipe the final grades right through an output stream using something like PrintWriter. So I'm going to leave you with this. Based on everything we've unpacked today in this explainer, how will you combine these storage arrays and I/O streams to build your very own processing systems? The tools are incredibly powerful once you really see how they all connect. Give it some thought, and happy coding!